Welcome to the short revision video on timers of 8051 microcontroller. 8051 microcontroller has two 16-bit up-counting hardware timers T0 and T1. They can also be operated as counters C0 and C1. When an internal standard frequency pulses are counted, they generate a standard time delay and are used as timers. When any variable external frequency pulses at pin T0 and T1 are counted, the hardware operates as counter. Each timer has two 8-bit registers to count 16-bit numbers. Refer to the figure for the name and address details. Configuration and control of hardware timers is done by the bits of TMOD and TCON SFRs. The TMOD register. Lower nibble is for the timer 0 and higher nibble is for timer 1. The bits M0 and M1 are used to select one of the four modes of the timers. The bits and the modes of operation of the timers are entered in the table that you can view. When the bit C bar T bar is set as high, the hardware works as the counter. When the bit is set as 0, the hardware is configured as timer. When the gate bit is made 0, then the run is controlled. The timer or the counter run is controlled purely by the software bit TRX of the TCON register. When the gate bit is high, the timer and counters are controlled by an external switch input connected at pin INT0 bar INT1 and the software bits TR in the TCON register. In the table, you can observe that the gate entries are differing with what I told. That's why for this gate entry, this will be for the 0 input and this will be for the high input. Please make the changes. The TCON register. The lower nibble is for two external hardware interrupts, IT0 and IT1, wherein the bit 0 and bit 1 represents the interrupt 0 bits. When the bit 0 is 1, interrupt occur on the falling edge of INT0 pin. When bit 0 is made 0, interrupt occurs at the low level status of INT0 pin. When the bit 1 is high, it indicates that the external interrupt 0 has occurred. And when the bit 1 is 0, the external interrupt 0 is not still processed. It is processed. Bit 2 and bit 3 are the similar bits for the external interrupt 1, wherein bit 2 indicates the type of trigger selection, whether it is a falling edge triggered or it is the low level triggered, and bit 3 indicates that if the interrupt has occurred or interrupt has processed. Bit 6 and bit 7 are the similar flags, the run flag and the timer overflow flags for the timer 1. Now this diagram explains the control process of the timer and counters, and this is called as the logic diagram of timer bar controls, timer bar counters. Now the internal standard F oscillator divided by 12 pulses are available at the upper terminal of the selector switch here. The external variable frequency pulses from pin T0 and T1 are available at the lower terminal of the selector switch here. When the C bar T bar bit is 0, the upper terminal is connected through the selector switch and the hardware is used as the timer. And the hardware is used as the timer here. When the C bar T bar bit is 1, the lower terminal is connected through the selector switch and the hardware is used as the counter here. When the gate bit is 0, the input and output of the OR gates are 1. When the TR bit of the TCON is made 1 here, the output of the AND gate turns 1 and this pulse is connected to the control switch here. With the 1 at this control switch, the switch is closed and the pulses from the previous stages, any of these stages, will be connected to the next counting stage. When the gate bit is a 1, the input to the OR gate is 0 here. Therefore, OR gate output can be made 1 only by giving a high input from the external hardware pin. With this 1, only the OR gate output can be made 1. And when the TR bit is maintained 1, the hardware input from any INT 0 or INT 1 pin will be giving a high output at the AND gate output, and this high output will be closing the switch here and the pulses from any of these circuit will be flowed to the next counting stage. As seen in the mode of this timer selector table, timer can be operated in 4 possible modes. In mode 0, the timer operates as a 13-bit timer, wherein the lower byte will be using only the 5 bits for the counting process, and the higher byte will be using the full 8 bits, so that totaling up to the 13 bits here. And this timer can count the maximum number of input pulses up to 8192 decimal value. When the overflow has occurred, a timer will be setting, the timer will be setting a overflow flag wherein this TF flag, that is the timer overflow flag, will be set as 1. This is the model of timer in mode 1, wherein the full 8 bits of TL and TH are used. For your proper write-ups in the book, you interchange the position of this TL and TH so that always the lower byte will be incremented first and the higher byte will be incremented next. And that's always the better to use TL first and TH next, wherein the counting pulses are input from this stage and the pulses from this stage are counted through the TL first. When the TL overflows, and TH will be incremented by the overflow bit of TL. When TH overflows, then we say that the 16-bit register counting is overflown, and this overflow will create a high bit on the timer flag, that is a TF will be set as 1. The same is given as the example. If the initial values are like this, with the increment of the timer counts with each bits from the counting stage here, the pulse generation stage, when the rollover occurs at this register, the timer overflow flag TF will be set and the register will be reset to 0. This is the mode 2 operation of the timer, wherein this mode is called as the 8-bit auto reload mode of timer, wherein only 8-bit register TL is used for the time pulse counting process. The initial value will be loaded into this TL register first, and each pulses from the previous stage or the pulse generating stages will be incrementing the count of this TL register. When the TL register reaches its maximum value of FFH, means 255 decimal value, the overflow will occur and the overflow flag will be set as 1. This overflow flag, as it is connected to a tri-state buffer here, it will be automatically reloading the value which is stored in this TH register again back to this TL register, and TH will be storing the initial value from which the counting has to be continued, and therefore from that point onwards the TL continues counting and produces a periodic pulse at TF bit. This is the sketch of the timer in mode 3 operation. This is called as two 8-bit timers using timer 0, wherein TL0 is independently acting as one of the register for the timer, split timer, and TH0 will be used as another independent register for the split timer. Here, this timer using the TL0 can be operated as a timer or counter, and it uses the control bits of timer 0. That is, it can be started and stopped by TR0, and the overflow flag can be set or cleared is TF0. Whereas another split timer which is using TH0 can be used only as the timer, because it is having no external input provision, no external switch input provision for the same timer 0. That is why this can only be used as the timer, and the maximum count that is possible using both these timers is equal to 255 decimal only. And this particular timer uses the control bits of timer 1 for its run and overflow bit settings. So this is the fast recap of the timer theory topic. Include essential details while answering questions on this topic. Practice it well.